And if you have tokens, it's good for that. If you need more tokens, you can harass sponsors to give them to you, or we are selling the tokens up at the front desk as well. They're $5 a drink, which is about half what the hotel charges for the drink. So, but we want to help out. So with that said, I will hand it over to Grecs. If you are not playing with any of our 2 CTFs, please check them out. We have the nice pyramid technical CTF going on all the way down the hall, and then the open source stuff. Last I checked, so few people were doing the open source and the Twitter-based CTF that victory was like guaranteed. And come on, you can definitely win. So go check it out.
All right, how's everybody doing? You know the thing I like about NolaCon? First talk is at 1 o'clock. That's awesome. Oh, it's 10. Shoot. All right. Well, at least I got to sleep in today. All right. So today, I'm going to just give a basic network monitoring and analysis talk. So we're going to go through this. So traditional disclaimer, these are my own views. They're not the views of like my family, my kids, my wife, my in-laws, people that I work for, customers, stuff like that. So these are all mine. So I hail from the Metro DC area. So is there anybody from Metro DC area here? No. Well, I knew a few people that were going to be here, but so a little bit about me. So I've been in industry for about 20. I think this slide's a year old, but I've been in the industry for maybe a little over 20 years. Probably about 17 of those years have been focused on information security. Prior to that, I was just basically doing IT type stuff, which is where I learned all the basics and all the different IT realms that really helped when I transitioned to a security and transitioned to a career in information security. The past 5 or so years, I've been working in more of an operational environment, doing SOC type stuff. But as you can see there, over the years, I've done a lot of things. I started out doing fun stuff with like pen testing and web application testing. And then I got into more of the paperwork type stuff in the middle of my career. So doing like security engineering, working for the government, doing FISMA type stuff for accreditation, did props and fun, and that's really fun stuff. But at a certain point, I decided that hey, I wanted to try to get more into doing some of the technical aspects of security. So I was able to land a job just doing kind of trade studies with looking at all the different products that are out there and doing bake-offs. So that was fun. And like I said, the past few years I've been working in a SOC, everything from an analyst all the way up to now where I'm mainly doing training, and I'm also just, I guess, sort of advisor. So, trying to help people make their SOCs more efficient. So this is my website if you want to check it out, novainfosec.com. I've been running it since 2008. So I go through periods where I'll blog a lot, like sometimes 3 times a day, and then sometimes where I'll do like 1 a month. So just depends on how much time I have. So doing, trying to, like everybody else in security, I'm trying to, start up my own thing because I'm tired of trying to work, because I'm tired of working for the big man and making money for them and not myself. So if you're interested, hit me up. All right, so today on to the topic that we're going to be talking about is monitoring and network security. So just go through a little introduction, talk about an environment of how you can set this up to learn it yourself, or set something up in an enterprise environment, the methodology for how to go through. So if you're an analyst, what's the process for going through that? And then secondly, where to learn more, both for people that want to get into it, as well as analysts that they may have certain knowledge gaps to help fill those. And most of those are all free. And then the next thing is, what now? So you've heard this talk, you've done these things, and, what can you do now? All right, so first I want to talk about just, why I'm doing this, and just some basic definitions too, just so that we all get baseline to the same level. So the first one is, it's for, I don't know, I look at it, somebody like myself, where mid-career, I was doing more paper-based security and I wanted to get more hands-on. So it was a great time for maybe general security practitioners to go in and, get back into doing some of the hands-on stuff. A lot of the knowledge that they have was very useful, and so it wasn't that bad of a transition. Plus, it was in an operational environment, so it was a lot more fun. If you spend too much time designing security, you have these theoretical understandings of, these academic understandings of how stuff is supposed to work. But when you get in the real world, stuff doesn't work like that. So it's good to get that experience regardless. And then the second group is, maybe you just started working in a SOC or doing analysis, and kind of giving you a career path here, how to do your job more effectively, and also if there are any specific knowledge gaps, trying to give you sort of the map of what needs to be filled. And then lastly, it's kind of fun. We all like to watch TV shows and mystery, and we're going to solve the crime and stuff. And so, essentially that's what it's kind of like, so you're going to get in there, you're going to get this alert, and then you're going to have to, learn as much about that alert as possible to determine, hey, is this something that we're going to investigate further? Is it something we can investigate further? And then make the decision if you want to go down that path. So the first thing is, so how many of you here have, worked in an operational environment like a SOC or something like that? Okay. All right, so keep your hands up. All right, so for the people that are brave enough to put their hands up, so how would you define what network monitoring and analysis is? Oh, everyone's lowering their hand now. Anybody? I have candy. Oh, shoot. I should have got that. What's up, man? Hoping you can spot a pattern quickly and way too much. Yeah, all right. Any other thoughts? Oh, wait a minute here. What do you like, Twix or Snickers, Milky Way? Nothing? No, I don't. All right. You can tap somebody that if you want to give it to someone else. All right. What do you? Okay. Damn, we're all getting old. Go ahead. Or do you want? What do you want? Milky Way. All right. Ah. Ooh, nice catch. We're all getting old and watching our sugar and all that kind of fun stuff. We're no fun anymore. All right. Is there anyone else that wants to take a, shot and get some free candy? I need to have like really good candy, apparently. This is not a motivating factor. All right, so my funny answer is it's basically the monitoring and analysis of networks. Ha ha ha. All right, so and this is from Richard Baitlick or Tau Security, if you follow him on Twitter. In one of his old books, I think it was written like 2002, 2003, and so he basically defined it as the collection, analysis, and escalation of indicators and warnings to detect and respond to intrusions. So that's a formal definition. I'm a process guy, so I wouldn't say a process guy, but more like a framework guy. So I like to have kind of a path laid out, and so I kind of just tentatively kind of broke things down into there's a selection phase, there's a triage phase, and there's an analyze phase. All right, so keeping that in mind, so for those that have worked in SOCs before, like, what do you think? How would you define what goes on in a selection phase? Okay, signatures. So you're gonna select stuff based on certain signatures. Okay, so that's foundation. Milky Way. All right. Oh God, my arm's gonna kill me after this. Oh shit. Damn. All right. No lawsuits. All right. Anybody else? Selection. What's the selection process? Like, how do you select the alerts that you're going to look at? Anomalies, sessions. All right. Oops. All right. I'm going to just start throwing them out there at random people. All right, so that's enough of that. So really, it's just basically just, dumb choosing an alert to investigate, just kind of like what you guys said, there are different ways, and we'll go over that of how to choose them. But the goals are to really, choose the most high quality and relevant alerts from the sensors that are out there. And really, we're looking at, not necessarily what the vendor says is high, but, the keyword here is relevant, trying to distinguish out of all those alerts that are flooding our systems, which one are relevant to your organization. All right. So then the order, so it really varies by organization. Some organizations, if they're just starting out, it's probably just loosey-goosey, just do whatever you want. If it's more mature, they probably have a process that they want you to follow. Generally, like going from, some high priority events all the way down to low priority events. All right, so I thought I missed a slide there. All right, so the next area and like the second phase here is triage. And so how would you define what triage is? Does it say what it's supposed to? Okay. All right, so what you're expecting traffic to look like versus, what it's actually doing. All right. Oh. All right. Sorry about that. Which person? Let me get bad reviews. All right. Anybody else? Go ahead. Yeah. Yeah, so really just like he made the medical analogy wherein you're in the battlefield and trying to dive into like the things that you can be saved now versus stuff that can be pushed to later. All right, and you don't want any candy. I'm gonna stop throwing candy, but think people are mad at me. But all right, so basically quickly separating the alerts needing further analysis from the irrelevant ones, like at least in the security realm, that's how I kind of look at it, because depending on how mature your sensor admins are, you could be flooded with stuff. So, really being able to parse through that and pick out the stuff that's most relevant to your organization. So the goals are to identify alerts needing further investigation, just sort of restating that. And the activities that you're going to be doing here is you're going to be really looking at the alerts in further detail to discover why it fired. Well, hey, this signature fired, and sometimes you can get a little bit of network traffic, and looking at the network traffic and saying, well, hey, we were trying to alert on the keyword secret, but it may be somebody emailing somebody else saying, oh, here's the secret book, or here's the secret anniversary location that we're going to meet up, right? So it may not be as bad as what you think. And I think one of the most important things here is whenever something fires, if you get past that point, is to look through the prior knowledge that you have. So for most organizations, this is going to be incident reports, but I encourage SOCs to have other, I guess, like kind of analyst knowledge bases where they can document common things so that as new people come in, they don't have to reinvent the wheel. And then lastly, just doing some basic open source analysis as well as some internal analysis to determine things like, all right, well, let's look at the source and destination IP and the ports and protocols to determine if this is something relevant. Like say it was like a Linux attack against like a, Microsoft web server. Well, we really don't care too much about that. All right, and so the last area that we're looking at here is an analysis. And based on the first two phases, What do you think I'm talking about here whenever I say analysis? Okay, looking into the incident. So what types of things do you think we would be doing there? Yeah. Protocols, malware, source, destination, IPs. Yeah, everyone's. Anybody else? Go ahead. Response traffic, yeah. How often it happens, if there's damage, what that damage is. Okay. All right, now I'm not going to throw these anymore, but if you want to come up and you asked a question and you just want to get this, I'm going to leave these up here for you to grab. All right, so I define it as, so you have your primary sources, which are usually your sensors, and then there are a lot of these things that aren't specifically sensors, but they're devices that are supporting resources to determine the validity of that attack. And so the goals here are to determine the actions that the attacker may have taken within your network. Key activities that you would be doing here is basically the key indicators, which you've found probably from your alert, such thing as like IPs, domains, ports, things like that. Using those as pieces of data that you can pivot off of to go look through these data repositories. So things like, hey, I'm going to look at like NetFlow stuff, and if you're lucky enough to have full packet capture, being able to dive in. And there's a whole bunch of resources here that a lot of people don't take advantage of, and I'm going to talk about that a little later. All right, so the environment. Okay, so the first areas that I want to talk about is, really what is, so we're talking about the sensors here. And this doesn't, so traditionally we're talking about like an IDS or an IPS, and it can be network-based or it can be host-based. But if you look at that more generically, you have different sort of detection systems for almost every protocol. So you have stuff that focuses on email, stuff that focuses on, web applications. There's, your fancy stuff where it tools that, strip attachments out and try to explode them in a chamber to see what they do. So just think of it that way. So it's definitely, nowadays much more than just a basic network IDS. And then usually there's two types. So there's signature based, which is like, hey, well, whenever this attack is done, there is this specific series of characters, and
Hi folks, I'm Geek here again. Unfortunately, the Advent Media has yet again failed me, and you have to fast forward to about the 19-minute, 35-second mark before the audio will resume. Sorry for the inconvenience, and yes, I am looking for better video capture devices that do not fail me.
all right, so I can't walk over there. All right, so you have stuff at the network level. Traditionally, you're starting out with NetFlow, which is just basically, network statistics, based on source and destination, IP and ports, determining who talked to who and how much data was transferred. So NetFlow, the advantage of that is it's relatively small, so you can store it for long amounts of time. Great for doing hunting stuff that may have occurred like 6 months back. And the second is full packet capture. And so, depending on the amount of traffic that you have, you may be able to store like a few days of this. The goal would obviously try to get, 7 to 10 days or 30 days, but depending on how much funding you have, that may not be possible. So the other thing, that's the actual network traffic, but then you have the logs that are sort of, or the device logs that are helping transmit this information throughout the network. So there's things like just firewall logs. I mean, those are tremendously helpful. Just looking at connections that are set up, torn down. There's certain protocols that like FTP that have a lot of information there. And the same thing with routers and switches. There's all the logs associated with those. So then you have application logs. So think of like your mail server, your web server, file server, DNS, whatever. So these are the logs that are associated with that. So, right now, like DNS is big, and I think proxies have, especially like HTTP proxies, have always been big because a lot of traffic goes over HTTP because it's a wide open hole. So, that's used as an attack vector, as a C2 vector, as an exfil vector. So, if you have proxy logs, you can actually see a lot of that stuff happening if you didn't stop it. And then other detective or preventative sources is, you may have an IDS system that has low alerts that you would normally just ignore. Well, whenever, like, you can also use those low priority alerts in your sensing infrastructure to, gain more information about a potential attack. So they can be not only a primary source of alerts, but they can be, as a supporting resource as well. So then external, there's like a gazillion places on the internet where you can go and grab stuff. So, just with the stuff that I've done and the stuff that I teach and a lot of people that I talk to, I've tried to put together like kind of a basic list of where to start. So there's a lot other places. Obviously Google is a big resource. I mean, a lot of times you can just, if there's an indicator, you can just search for it and like an IAP and see what comes up, or a hash or something like that. There's also I think it was Jack Crook put a few years ago. He put a customized search engine, or a customized Google search engine together called Active Threat Search. And so he did the same thing where he found like the 20 or so sites that he always uses for doing OSINT, and he created a customized search engine for it. So you can probably just search for that. It's a good resource. And then definitely when you're dealing with like IPs and domains, looking at, who is DNS type stuff. So a lot of.
And yet another AverMedia glitch, but it's starting the audio back up very shortly.
Good? Okay. I didn't move that time, I swear. So passive DNS is huge. And then you also have your old, traditional command line type stuff, such as NSLOOKUP, dig, whois. So the next category is reputation databases. So URL query is the big one. So, I recommend, if you're going to check out a site, definitely doing the search first to see if someone else has searched on it. There's this theory that if you get an alert and you submit a live analysis to your URL query, that you're hitting the attacker's infrastructure, and that's tipping your hand that you know how to detect them. But depending on the sector that you're in, that may or may not be of significance. And then there's URL void and IP void. So those are just kind of meta engines that pull together data from various sites that measure website reputation and IP reputation. Web archives is huge. So Google Cache is always a fun, like a lot of times if you'll find out, like if you're going to go try to see the adversary's infrastructure, maybe it's a website or whatever, you could just Google Cache it and not hit it directly. And also the traditional Wayback Machine. And then passive scanning, so I'm not talking about doing active scanning, say with Nmap, but there's a lot of tools out there that are already just scanning the internet, so why not take advantage of those results so that we can learn about what the attacker's infrastructure is. So traditionally, I think most people here have heard of Shodan, awesome stuff there. Just put in IP and get tons of information associated with it, ports that are open. For each one of those, you may have banners. So a lot of good stuff. In the academic realm, there's something called I heard about it recently, but it's called census.io. So that's another resource you may want to check out. And this was released like a few years at ShmooCon. I don't know, probably like 4 years ago. But it's called Punk Spider. So work continues on that, and that's focusing on web applications, or websites. So it'll go and scan a website and determine what some of the basic vulnerabilities associated with it are, or if it's good, and then just throwing it in there. Just kind of old school. The netcrafts. What's this site running if you want to learn more about it. So then are the meta sites, right? So VirusTotal. Obviously, it started out where you could just submit files and then that file scanned by like 30 AV engines. But it's really evolved into, all right, well, you can do the same thing. You can submit URLs to it. You can search for it. You can search for hashes. There's even, I don't know who they're working with, but they seem to be doing behavioral analysis too. So if you submit a file, if it, through one of its partners, it may pull in some behavioral analysis, sort of a detonation and what that did. So passive total, as the name, this is kind of your passive way to learn as much information as possible. It started out as being more of a passive DNS type service where you could search, and it was free, but now they've gone commercial. But for like the average user, like you get, I don't know, like 50 free queries per day. So go ahead. Okay, cool. Yeah, so if you're a researcher, you can email them and they may bump you up too. Now they started out with passive DNS, but they're also pulling in a lot of other good stuff too. So excellent site to check out. And then lastly is ThreatCrowd, which is a crowdsourced site. They have a, you put an IP in and it'll pull in some information about that and from various resources, so that you can get a better understanding of that. And it has this cool kind of graph where you'll have your IP in the middle and you can click on it and you can pivot around and stuff. It looks really cool, but to be honest, I would just rather write it down on the notepad next to my keyboard, but it's kind of cool for management. All right, so the third the last main component of your environment here is some place to store this all. So a centralized place to pull all this stuff into one place. So the sources include obviously your sensor alerts, logs and stuff from all your different supporting resources, And I have external resources here, but it just I just wouldn't pump tons of external stuff in. I would find the stuff that's most useful for you and maybe keep that, and then for the rest of the stuff you would just do live searches. So whatever this device is, you configure it to show alerts. If it's a SIM type thing, maybe you can correlate multiple alerts together to make it to increase the alert fidelity. So there's two aspects. There's kind of like your pure SIMs, which are things like ArcSight or tons of other ones that are out there. Just get started. Alien Vault, it's based on open source, so you can start out with that, and then they have a commercial upgrade path. But there's a whole bunch of them out there. If you want to do, and I didn't know how to categorize this, but more like adaptions. So, Splunk is, more of just a great place to just put all your logs in. They've written modules so that you can have sort of an alert pane. It doesn't do correlation as well, but I don't know. Personally, I see money go in and invest money in all these expensive SIMs that can do correlation, but then no one's ever using it. So if that's a situation, you could go with something like Splunk, and it's free for I think up to a certain amount of data if you just want to check it out. Love Splunk. And if you want to go open source, the technology to go with is probably more of the Elk stack. So it isn't that bad to set up. It's pretty clean. It takes a few minutes. So even I did it. So putting the whole big picture together, it looks something like this, where you have your, the blue. This is where all your analysis data is pulled together. Maybe you have, your log collector there, and maybe your log collector is acting as your central place to find alerts, or maybe you have a SIM that's doing that. And then you have your analyst workstation. So on your user LAN, you're usually having some sort of an endpoint security solution. So, just your traditional AV, HIDs, whatever that is out there. In the server LAN, you basically have the same thing, but those agents are, more focused on doing server stuff. And you definitely have all these green things, all the data associated with those. There's logs there, and you can use that as a supporting resource. Same thing with your router. So having some sort of a network intrusion device, you can place that wherever depending on what your strategy is. But here I've just placed it behind the firewall. And then you have your firewall logs, and you maybe have your web server logs and your email logs, and you may have agents on those machines as well. Your full packet capture sitting wherever, if you're just starting out, maybe you just have full packet capture for a limited amount of time from sitting on the outside. Maybe you want to conserve, so you would move that to the inside. And if you get real mature, maybe you'd have full packet capture on each of the different LANs there, so that you can see inter LAN traffic. And then you have your stuff that you can get externally, such as all the OSINT stuff, like Google, the Whois stuff, etc. So where to start out here? So integrated environment that you can kind of start with is, it's been around for a few years now. Doug Burks put out Security Onion. It continues to evolve. I mean, this definitely isn't something that you want to work on, that you want to use in a big enterprise. But if you're, small and you're just starting out, this is a great thing. It's a great solution to get going. And then Doug has, he's working to try to come up with a box that people could just buy that has all this integrated together as well. But essentially, you just need just an old PC that's lying around. It has various different different deployment options. There's 3 components, and you can either have them all in one box, or you can distribute them however you want. And essentially, like I said, you just need this old beige box, and you need some sort of a router that supports mirroring or tapping. And for, if you're doing this at home, or if a very small environment, like the Netgear Pro safes are good to start with. The other one that I like is pfSense. So this is essentially a firewall distro based on Debian. Once again, I just had an old desktop. I just installed this thing, put a few extra NICs in, and I was ready to go. It does all the automatic updates. Like I can see just one push and I can get it updated. It has tons of modules, so you can add stuff to it. By default, it's just a firewall, but you can add, they have, there's a snort module that you can install on it. There's a proxy module. There's even you can run OpenVPN on it, but there's tons of stuff there. It's a very nice system. They also sell it as a little box. I think it's like a little Netgate box. So that's very useful as well, and you're helping support them too. So Security Onion, just to break it down, and some of the different components that it has, it's based on Ubuntu. From an IDS perspective, it has Snort, Suricata, and Bro. From host intrusion detection system, it supports OSSEC. From a supporting resources, so it has NetFlow, so you can have, the two big ones there are Argus, and then Bro has sort of a NetFlow, like their connection log, so it's NetFlow-like. And then application and protocol logs, so Bro, so that's basically, if you don't have your actual application logs, Bro basically reads all the network traffic over it and creates application-like logs. So that's very useful. So for as an example, if you didn't have an HTTP proxy, it has an HTTP log that is sort of what is it called? HTTPry or HTPry. I forget the tool, but it will produce web server type logs or mail type logs. So it's a nice in between just the NetFlow, which is purely just network stuff based on the 5 tuples, and full packet capture. And so a lot of times, instead of having to go to full packet capture, you can just look at NetFlow and look at your Bro application logs and really have a good understanding of, is this something I have to worry about or not? And you don't even need to jump to the full packet capture. Then from an analysis point, so it has various interfaces. So there's, can't even read it on my screen, Squeal, Squirt, and another one that I can't read. What does it say? Snort. All right, my screen's a little messed up here. Or I'm getting old and I need to get new glasses, but whatever. So just various interfaces for looking at all the traffic that is being detected by the sensors. It has a SIM sort of logger with the ELSA. And then there's some miscellaneous stuff there, such from an analyst perspective, such as Network Miner and Wireshark, and it's Linux-based, so it has all those other cool things that you can do with it too. So you can log in and parse through logs manually as well. So as I said, there are various deployment options. So you can either just have the box set up as all 3 components together, just sitting at one place and just watching it there. But if you're pushing it out, you're probably going to separate out your sensor to where you want it to be, and then you can have a server that is probably inside your network somewhere, so the sensor kind of feeds the server, and then there's a console aspect to it, which is what the analyst would be working at day to day. All right, so we have this environment and we kind of know what it is, but the next question is, how do we do it, right? And so just trying to go into the methodology here. So the first phase is your selection phase, which I talked about. And essentially, like we talked about earlier, it's choose an alert to investigate. Organizations may already have a process or a priority like this set up. So, one method, which I have it there as right, is usually, hey, maybe, high priority based on vendor SIGs, and maybe custom signatures you wrote would be the next priority, and then you get down to, I think this gentleman talked where you would look at, you would group alerts and do counts. So you can group them on alert type, but you can also group them in other ways, such as on the target IP, the victim or the attacker IP, and you can do the same thing with ports too. So you can look at the data in different ways. Where you have a lot of hits, you probably need to talk to your sensor admin to look at that and figure out how we can make the signatures more have more fidelity. But where you have just a few hits, those may be things that you may want to investigate further. So then maybe you would go, and then after that you would maybe, the vendor says this is a medium alert. Maybe you would hit that, and if you can get through them all, then you can go all the way down to whatever the low ones are. But most people can't get through them all. So tips here, if you're just starting out, don't cherry pick. So I worked in environments where they basically say, all right, well, your performance is based on the number of IRs or incident reports that you put out. And so people just cherry pick the easy ones and they put all these things out. And then, all right, that's not good. You're not only, first of all, you're cheating yourself, especially if you're starting out, because you're not learning, and you're also cheating your organization because there may be more, more threatening alerts that need investigation. And also, if there are a lot of alerts that you're always are seeing as false positives, work closely with the sensor admins to, really add more fidelity to those signatures, or, get them to turn them off, because, the more stuff we have to go through, the harder it is to find stuff. So the second phase was triage. And so this is where you're going to examine the details of whatever alerts you selected to find out why it fired. So here, you're usually going to start out with, if you're in a SIM, you may start out in a SIM and look at all the data that was passed to the SIM. You may look at other, within the SIM, you may look at, all right, well, what else, what other alerts do we have with this target IP or this attacker IP, or maybe this alert type? And so there's a lot of stuff that you can determine there. Or you may kind of dive down into the source that generated the alert. So maybe your IDS, you would go into Snort or SourceFire, and you would look at the alert, and you would look at the signature, and usually there's write-ups of, hey, check out this link of this particular attack. And especially if you're new, like, you definitely want to go and read those and learn them and make sense of it. Usually in the sensors, you're going to have at least some snapshot of what the PCAP looked like, of what it alerted on, so you can actually look at the PCAP there and make a quick determination if this was like a secret document that was being sent over the network, or if it was just somebody that used the word secret in an email. But eventually, all this stuff, you get to the point where you want to compare it with the prior knowledge, and the big step here is to save time. I think the military term is, force multiplier, right? But you basically, instead of you doing an investigation from scratch, if somebody did an investigation similar, you can go back and kind of do a lot of stuff based on, skip a lot of steps based on their work, so you can go through your analysis faster. And so I'm not only talking about incident reports that were formally written up, but if there's a way that the organization, like anything that you investigate, even if it's a false positive or it's not relevant to your organization, like even having a database of those type things available too is very useful, so that you can build up that internal knowledge so that you can look at events or go through events more efficiently. So here is, and I wasn't sure to put this step in the triage step or the analysis phase, but really, so looking at basic, source destination IPs, just, like I said, if it's a, if it's a Linux attack on an IIS web server, probably something you don't have to worry about. But if it looks good and you need to go to the third step, that's where you jump to the analyze step. And so this is where you really kind of cut into all those supporting resources that you've been gathering data data from, and based on what you've gathered so far, which are usually indicators, search through all the relevant resources, and learn as much as you can about those, and then you're going to be pivoting off those, because from one indicator you will find maybe an IP, and then you'll investigate that, and then you'll find another internal IP that maybe like an attacker pivoted to. So you'll be pivoting around, doing fun stuff like that. So this is, like, I didn't know what to call it, but everybody's coming up with chains, so I just called this the cycle. So I was trying to come up with like a unique analysis, I don't want to say step, but an analysis component to show people how to do it. And so I came up with this like indicator analysis cycle. And so you basically, like, there's usually some sort of a stimulus, which is an alert. And then you determine, from that alert, you would determine what the indicators are, search your knowledge base to learn as much as you can about it, determine where in all the logs that you have you can go look for it. So you're going to query that methodology. And then you get to the final phase where you're going to document the results of that in some sort of a knowledge base. And then you have two options. Well, could that indicator maybe occur in another log? Well, hey, I'm going to go there and check that out too. Or you may go through this whole process, and this is where you would pivot off of, right? I started out with IPA, and oh my God, I discovered like IPB might be infected too. And so you essentially just start the process over again. And then it sort of comes up and it looks something like this. So your iterative process, and eventually you kind of do all the analysis that you need to do, and things start to fold back, and you're done. Obviously, I think most analysts don't have enough time to like comb through, like follow this process all the way through the end. So so that's where you come up with different philosophies. It's really, the basic premise here is to hypothesize, based on what you know, what the attacker could do, and then look for evidence associated with that. A few different ways of doing that. I mean, you can use timeline analysis to kind of lay things out, to put stuff in place. A lot of the intelligence frameworks out there, you can use those to, right? If this is an attacker and I detected them in the install phase, all right, well, if I work backwards, I need to find the exploit, I need to find the delivery, etc., and then maybe work forward too. So, and there's there's a bunch of different Intel frameworks out there. I won't mention any, but basically just go out and choose the one that works for you. And if none of them work for you, just create your own and start working with it. So where to learn more? So there's Jack Kroc. It's his Twitter is on the screen here. I think I miss. Yeah, it's what? Okay. Oh yeah. Jack CR. Sorry, but yeah, you can check him out. I follow him on Twitter. But he came up with his blog post where he was doing a training plan for the analysts, and it was pretty high level. And so, like, I used, and this was a few years back, and I used that in some of the training that I put together too. But basically, some fundamental stuff that you definitely want to learn up on if you want to, if you want to become a ninja in this field is, so the first one is Linux. The great thing about Linux is all your analysis tools that you need are built in, right? And you're doing command line stuff, so you can definitely, it's harder, but you can definitely take analysis a lot deeper and do more advanced things, where GUI's sort of like you can only take analysis so far and you hit sort of a limit. So I just list like some, Linux. I mean, you don't need to be like a Linux guru. You just need to know some basic stuff, just basic commands, how to do listing, make directories, change around, how to get help, right? Because then you can just do that and to learn new things. Intermediate, being able to use things like grep and word count and stuff to gather basic stats. Strings is also big. Depending on what you're doing, operators for directing your output, or for reading output in and directing it out, and also piping different commands together so that you can do really advanced cool stuff. And then advanced stuff, where you start doing more statistical type stuff, where you can do, sort, unique, you can cut, xargs, a whole bunch of like regular expressions are awesome for being able to find stuff. And then learning some of the scripting languages like awk-sed for just doing basic parsing of data, bash, just learning that, and then Python's big too. So the other fundamental is networking basics. So just understand the basic networking concepts, the whole OOSI model, TCP IP stack, common ports and protocols, but also understand what it looks like. Don't, understand what the TCP handshake is, understand, what an HTTP session looks like after that, what an SSL session looks like, etc. So really, be able to bring those things up in Wireshark and be able to just quickly identify them. PCAP analysis, so I already talked about Wireshark, just being able to use that tool as much as possible. And also like command line stuff. I mean, there's, T-Shark, which is the command line version of Wireshark. There's also TCP dump, but then there's also a lot of like interesting tools that are in Linux by default, like little scripts that will automatically go through and pull out attachments, or you can do regular expression searches through the binary PCAP. Like just lots of cool stuff there. And then flow analysis. So, basically understand that, how you can use it. I talked about what that was. So the tools, Silk is kind of the big analysis framework. But like I said, if you can use, Security Onion, and you can just learn Argus, and it's command line, so it's not as fun, but you can really carve up the data and grab some interesting stuff. So the final part is log analysis, and so on the network side, this is just understanding. I mean, you don't have to be an expert, but just understanding the basics of all the different logs that are out there, and then being able to Google the rest if you need to dive in to more detail. So I have, proxy logs, your firewall logs, and certain protocol logs there too. And then the same thing on host. Most of us are, most enterprises are Windows, so, you have all your Windows logs. You may have endpoint security solutions. So being able to, pull those off the host, or pull those off of the management server associated with them. And like I said, you don't have to be like a super expert in all these, but you need to know the basics and just be able to use Google very well. So there's where to learn more. So opensecuritytraining.info. I'm a big fan of them, and they have a whole kind of school of SOC type thing. So there's a lot of good stuff there. Just kind of pulling that out. There's, some of the active classes that they have now are the ones at the top there: flow analysis and network hunting, introduction and network forensics, PCAP analysis and network hunting. A lot of those, they'll have videos that are recorded. They'll have labs with VMs that you can download, PCAPs that you can download, and then slides too. So it's a great resource that people are sort of like open knowledge, that people are publishing stuff there. For training and certifications, I mean, if you can do SANS, the GCIA and the GCIH are really good. If you're in the federal space, they kind of specify those two SANS cert, and then they also add the CEH, which, I'm not really sure about that, but I guess somebody paid them enough money. And then you have vendor certs too. So, if the company that you're working for uses ArcSight, or like, I don't know, Nitro or Alien Vault or whatever, there's training usually associated with all those tools. And same thing with your sensors too. And then Doug Burks has a Security Onion course, like if you want to stick with the open platforms, that he gives probably like once a month. So definitely check his course out. I think he just finished one this week. Defensive challenges. So definitely, and this is where I learned a lot. Just there were these things called CyberQuest a while back, and they're still doing them, but they're for high school students. But hey, if you're just learning it, you just get on and learn as much as possible. So you'll get PCAPs and memory dumps, and then you can basically do analysis on that. But just some top ones that I recommend are, there's tons of them out there, but there's malwaretrafficanalysis.net. So definitely check out his challenges. He does like one per month, and then he posts a challenge out, and then he posts the answer out a week later. Or you can submit for it, and I think you win something. And also, there's an old site called shellstorm.org. They have a capture the flag repo, and so it tries to capture a lot of the capture the flags from all the different cons over the year. So you can grab the artifacts, the questions, and do them on your own. And there's lots of other stuff there, and there's many others. So just definitely check that out. And just to kind of close things out, what now? Like if you're interested, and even if you're doing this now, first thing you should do is set up Security Onion at home and start investigating stuff that's going on in your local traffic. Kind of talked about the not cherry picking things at work. Make sure if you're getting tons of irrelevant alerts, make sure to work with a sensor admin so that you can tweak those to make them better or disable them. Never touch adversary infrastructure if that's your thing. You may be in an industry where you don't have to worry about that. And then the last thing is to know your network and your support infrastructure like inside out. I mean, as a defender, that's the only advantage we have. And I meet analyst after analyst after analyst that just has no idea. They're just like, I don't know. The sensor alert pops up and I do this. Well, where's that sensor sit? What other device is following that network path that you could investigate in to learn more about the attack, and knowing your infrastructure, where your sensors are, where you have logging devices, allows you to easily direct your analysis. And I guess I'll just kind of take questions afterwards. I never finish early, just FYI. But I do want to just give a shout out to NolaCon. This is the second time that I've been here. I was here the first year that they did it. So, Rob and Eric and the entire support staff, thanks for having me. You can reach me on Twitter. I'm at Grecs, my website. If you want to contact me, it's basically grecs@novainfosec.com. And I have little kind of ID/hacker cards if you want to see me afterwards. So with that, I'm going to kind of close it out and give the stage to the next speaker. Thank you.